everyone. Today we are going to solve Leetcode problem number 33, search in rotated sorted array. Okay, so we are given an integer array nums and it is sorted in ascending order and a target which we need to find if it exists in the rotated sorted array or not. Okay, first of all, let us see what is a rotated sorted array. So if we take this example here, so this is the example, and we can see 4, 5, 6, 7 or in ascending order, that is sorted order. After that we have 0, 1, 2. Again, this is sorted order. Okay, so in order to say it is a rotated sorted array, first of all let's apply some rotations. Okay, rotation in the sense one rotation is nothing but, so you are moving 2 to the starting position and all the other elements you're moving to the next positions. Okay, if I apply one rotation, so this will become like, so 2 comes to the start and 4 goes to the next position because 2 occupied its position. 4, 5, 6, 7, 0, 1. So this is one rotation. Let's apply another rotation. So 1 will take the first position after next rotation. So 2, 4, 5, 6, 7, 0. And let's apply another rotation. So 0 come to the starting position. 1, 2, 4, 5, 6, 7. After third rotation, we can clearly see that all the elements are in sorted order. Okay, so this is called a rotated sorted array. A sorted array, if you rotate it n number of times, at the end you will receive an array which is a sorted one. Now let's see how we can solve this problem. Now the first approach is going to be simple and straightforward, that is a linear search. So basically we will be going over each and every element and check if this element equals to the target or not. If the element equals to the target, then we can just return the index of it. That's O of n time complexity because we are going over each and every element. Okay, let us look at the second approach. So in this approach, we will try to make use of a binary search. In order to find an element in the array using binary search, what we do is we divide this entire array with a mid pointer and then check if the target is less than the mid pointer value or not. If the target is less than the mid pointer value, then we don't have to look at all these elements because definitely we will find the target on the left hand side, because one important property of binary search is all the elements must be sorted. Can we make use of binary search here directly? Let's see. So the target is 0 and the mid pointer that I got for this array is 8, and check if the target is less than mid pointer. Yes, the target is less than the value of the mid pointer. So my target, if it exists, that should be present on the left hand side only if we are planning to apply a binary search. However, we can see our value which is present on the right hand side. So we can clearly see that you cannot apply a binary search directly, but there is a way you can apply binary search for this problem. Let us look at some of the rotated sorted arrays and then try to identify a pattern here. Okay, so I've taken some rotated sorted arrays, these things, and I've also added another array here. Can this be a rotated sorted array? Let's see. So let's say if I rotate this one once, this will become 0, 1, 3, 2. Okay, after rotating all the elements, this is still not forming a sorted array. Okay, and even if I rotate it again, 2, 0, 1, 3, this is still not a sorted array. So this is not a candidate for rotated sorted array. Let me remove this and we'll try to find the pattern out of the rotated sorted arrays. First of all, we'll try to divide the array into two parts with the help of mid pointer. So for the first array, so the mid pointer is going to be here, and for this it's here, for this it's here. Okay, now if you observe on the left hand side, all the elements are increasing, and on the right hand side, so to the mid, so it is increasing, sorry, it is increasing followed by decreasing and then increasing. Okay, here On the left hand side, it's decreasing and it's increasing. Here in this situation, it's increasing. Okay, so one important observation we need to find here is when you divide the array with the help of mid pointer, at least one half will have continuous increasing sequence. So in this situation, when you divide it with the help of 7, so this part is strictly increasing. Here on the right hand side, this is strictly increasing. Here this one is strictly increasing as well as this one. Okay, so we will at least have one strictly increasing sequence. So if we have strictly increasing sequence, which means that all the elements on that side are sorted. So if you have a sorted array, we can definitely apply a binary search. So our goal is to find which side is strictly increasing. Once we find a strictly increasing sequence, now we will take our target and then see if our target is present inside this increasing sequence or not. Okay, so now let's take the same example, this one. So 4, 5, 6, 7, 8, 9, 0, 1, 2. Okay, and the target we are looking for is 0. Now the mid pointer is here, and we can see that the strictly increasing sequence is this. Now how do we find that in a program? So it's simple. So once you find the mid pointer, and we'll have a low pointer here and then high pointer here. If the mid pointer value is greater than or equal to the low pointer value, then left hand side is an increasing sequence. On the other hand, if the mid pointer value is less than high pointer value, then right hand side is a increasing sequence. Okay, that's how we can find which side is an increasing sequence or not. So in this situation, the increasing sequence is on the left hand side. Now we need to find if the target is present in the range of the increasing sequence or not. Okay, so a simple check is going to be if the target is greater than or equal to the value at low pointer, and if the target is less than or equal to the value at mid pointer. Okay, we're checking if this target is lying between this range or not. If it lies in this range, then we can apply a binary search on this to find the value. Okay, so as this condition, if this condition is not satisfied, then what we do is we need to find our target on the other side of the array. At that point, we can eliminate this entire thing. So on the first iteration, this entire thing will be eliminated, and the next iteration, so we will be left with this one, this array 9, 0, 1, 2, and the target is 0, right? So again, we apply the same logic here. We find the mid pointer, which is going to be 0, and then check which side is an increasing sequence. So here, this is a decreasing sequence, and this is going to be an increasing sequence. Okay, so this time the increasing sequence on the right hand side. Now we need to see if the target is present on the right hand side or not. So for right hand side, how do we check that? So here it's going to be if the target is greater than or equal to value of mid pointer, and if the target is less than or equal to value at the high pointer, value of high pointer, then we can say that the target lies in this range. As it is already present here, we can try to apply our binary search in this range. Okay, and in the next iteration, this gets eliminated and we apply binary search on this. So we'll be left over with 0, 1, 2. and we apply binary search on this, and we will return the result. So that is how we can make use of a binary search and find a target in a rotated sorted array. Okay, now let us see how we can implement this. First of all, we'll be doing a null check. So if unstored length is equal to 0, what we can do is we can just return it to 1, saying that element we cannot find anything, right? And for binary search, we'll take a low pointer and then high pointer. That's going to be num.length -1, and I'll do a while loop till while low less than or equal to high, and I'll calculate the mid pointer. It is going to be low plus high minus low by 2. Okay, this is to avoid overflow. And after calculating mid pointer, I'll check if the nums of mid, the value of the mid pointer, is equal to the target that we are looking for, then I can just return a mid pointer, okay, saying we found the value that we are looking for. Otherwise, what we need to do is we need to find increasing sequence. Which side is an increasing sequence? Let's take an example here. So, and for this, we'll have a low pointer here, mid pointer here, high pointer here. Okay, so how do you find which side is an increasing sequence? So we'll check the mid pointer against the low pointer. If the mid pointer value is greater than the low pointer value, then left hand side is an increasing sequence. Okay, so if nums of mid is greater than or equal to nums of low, then left hand side is increasing sequence. Okay, otherwise right hand side is increasing. You can also apply another condition here for finding the right hand side sequence, something like if nums of mid is less than or equal to nums of high, right, then this right hand side is an increasing sequence. For example, for that, so let's take an example of 7 0 1 2 3. Okay, if we take this example, low pointer will be here, mid is this, high is this. Okay, we can clearly see this side is not an increasing sequence, this side is an increasing sequence. And if you see, so the mid pointer value must be less than the high pointer value. That is what we're checking. If the mid pointer value is less than the high pointer value, then we can say that right hand side is an increase. Okay, or we can just remove this and then keep else. Both of them work. Okay, so to be clear, let's keep it like this. And once you find which side is an increasing sequence, and we need to find if the target lies in that increasing sequence or not. How do we find that? If the target, so we remember we are on the left hand side. On the left hand side, if the target is greater than or equal to nums of low and target is less than or equal to nums of mid, what we are doing is, so if the target, let's say is 0, we're checking if the target is greater than this low pointer and the target is less than this mid pointer, then what we are saying is we can find our target in this range. Okay, and we can eliminate all these values. So how do we do it in binary search? So we can just move our high pointer. If you want to move, if you just want to check on this side, what we do is we'll move our high pointer to mid -1. So that is what we will do here. High is going to be mid -1. Okay, if the target is not present in the increasing sequence, okay, because in this situation, let's say target we are looking for is 0 and the target is not present in this increasing sequence. So we need to check on the other side. How do we write that in binary search? So else low is going to be mid +1. Okay, this is simple. We do the same process for increasing sequence on the right hand side. Okay, assuming this is the input we have got. Okay, now again what we do is, let's say we apply the same thing. If target is greater than or equal to nums of mid, and target is less than or equal to nums of high. Okay, what we're saying is the target is greater than or equal to nums of mid and less than or equal to nums of high, which means that we can find our target inside this increasing sequence. So we can eliminate this entire other array. Okay, so how do we do it in binary search? Again, so what we'll do is, if we want to find it on the only this side, we will make our low point to mid plus 1. Okay, if we don't find target in the increasing sequence, what we do is we need to check it on the other side. So that can be written as high is going to be mid minus 1. Okay, so these are the conditions. If we cannot find our target value even by applying all these things, then we can just return -1. Okay, so let me comment these things. Let's see, and let me run the code. This is good, and let's submit. Okay, so this is how we can solve the problem. And one thing I've observed here is, as I'm already checking nums of mid with the target, I don't need to do this, because the target, if the target equals to the nums of mid, this condition gets executed and we don't need to check this. Okay, similarly, so somewhere here, so this one also equal to is not required. Okay, let me submit again. Yeah, this works as well. Okay, so this is how we can solve the problem. See you in the next video. Thank you.